Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I want to do today is talk about the high level of deployment. Okay, deploying your website. What does this mean? And some of the newer technologies when it comes to deploying, like serverless, containerization, etc. So that's the goal of this video. I'm trying to do this within 5 minutes. But deployment just means to get your website somewhere online where people can see it. And once upon a time, that could be very difficult if you weren't doing just a basic static website. So basically, you can go to most web hosts, get sort of your traditional web hosting where you put in your index.html. So your URL will automatically go to that index.html and everything's kind of simple. And you just build it up from there. But what if you wanted to create a website that had a little bit more featurist, had data, you made use of a database, kept track of information, had more rich backend processes? That's a little bit more difficult. One of the reasons why a lot of people just use WordPress and why WordPress powers so much of the internet, because a lot of that stuff is just really out of the box. Most web servers have the capability of running PHP scripts, so more so than pretty much any other language. So it's just readily usable, affordable, all that good stuff. So, WordPress is going to be around for a while. Now, theoretically, or typically, what you would do is you would have a server, and if you wanted to deploy this, deploy it without the use of a hosting service, you'd have to get a web server, so you can either create your own local computer or pay for a web server from someone else. You then have to install a web server software from it. So this would be like Apache or Nginx, which basically they usually take the requests. So basically what they'll do is they'll take requests on port 80 typically. So that's your standard web. So basically that's, I think, what's assumed when you send out HTTP requests, unless otherwise specified. So it send out an HTTP request, it would receive them at port 80, and then it would have all these files, all these config files, all these different files, kind of telling it, well, if you're looking for this website, send them to this folder. Here's the static files for that website. Here's the files for this website here. Okay, which, for your standard, again, static file website, probably not the most horribly difficult thing to configure. But when you start getting more complicated, for example, I had deployed a couple of different Python websites that used Django. And while Django is a very straightforward framework to use, when you want to use Python with Apache or Nginx, you have to use a interface, because they don't know Python, so you have to use something called uWSGI or WSGI, and then uWSGI is one implementation of it for using it with these web servers. So there's all this configuration that gets really tricky. Okay, so that's part of it. Part of it's also the cost. Oftentimes when you go get a web server, you're paying for a lot more hardware than you really need. Okay, and they can get a little expensive. So there's a lot of different new services out there that kind of try to attack this problem at different levels, whether it's attacking the convenience of deploying or the hardware, what you're paying for when it comes to deployment. So probably the lowest hanging fruit are and this is what's referred to as sort of infrastructure as a service. So they're selling you the infrastructure of web servers in different ways as a service. So probably some of the more popular platforms are like Netlify, which allows you to really just drag and drop a folder with your website on it and it's up and running, or Heroku, which makes it really easy to deploy a lot of websites with backends. Okay, and then they may be doing whatever they're doing on the back end to make that work, but the idea is you don't have to worry about it. They're abstracting away all that sort of back-end infrastructure for you. And then there's like virtual private servers. These are services like Linode or DigitalOcean, where what they do is they spin up a web server for you on the spot, and it's a virtual one. So you can have a really small one that's like $5 a month, or you can have a large sprawling one depending on the size of your project, and you can take your existing web server and then just scale it. Then there's containerization, which is like Docker, where basically you take your web application, you turn it into this sort of self-contained container that can easily just be copied from web server to web server and just work. And then now there's serverless, where basically your code sort of runs on demand. So instead of having a continuously running web server, you'd use something like AWS Lambda or Azure Functions, and your web application is really what's called a function. And whenever a trigger event happens, which could be a variety of things, an HTTP request to keep it simple. So you type in a URL, it would signal to AWS, spin the server for this application right now, run it, and once it's done being run and no one's running it, shut it off. So you're not necessarily having this continuous use of resources. And instead of paying for the server, you're paying for the seconds, the amount of executions. So for a web application that might, be occasionally used, you're probably not paying anything. But basically, as it grows, as it explodes, you just end up paying for sort of the extra usage. And there's a lot of debate over sort of what's the best for what application. Some things like VPS gives you a lot of flexibility, but you still have to configure the host yourself. But it can be really affordable, $5 a month for like a nano server on Linode or DigitalOcean. And especially if you're a new web developer, configuring something like that once or twice is probably not a bad thing for you to learn really what's kind of going on behind the scenes. Now, containerization, the thing about VPS though, virtual private servers, is they are creating a new kernel. They're literally creating a new instance of that operating system with each server. So there is overhead in that, okay? Which just means you're using more resources than you really need to, as far as CPU and all that stuff. So containerization kind of addresses that in the sense that you can have your sort of confined space for your application without having to create a whole new server, whole new kernel in the operating system. Okay, but you still have a continuously running server. That container's still kind of going and taking HTTP requests 24/7, even if nobody's using it all day or not. Okay, but it creates a way where you have this container. You can literally just plop it from server to server, and you don't have to worry about that container interacting with other containers and messing up their dependencies. You don't have to worry about all these extra kernels, because that was the reason for virtual private servers, to create that sort of separation between each application or batch of applications, depending on how you're using that server. And then there's serverless, where basically you have your separation between applications, but you also have the more efficient use of resources because it only spins on and off as needed. And again, different strokes for different folks, in the sense that there's different applications that make more sense for one. But serverless technology is definitely, cloud computing is definitely becoming a bigger and bigger thing. And the idea, when they say serverless, is not that there's no server computer somewhere. It's just that you as the user are not concerned about configuring a server, maintaining a server. That part of your infrastructure is no longer a concern to you. You just put your web function online, it runs as needed, your cost is less because technically behind the scenes it's not running all the time. And you are happy. And with that, you can actually then take a lot smaller use cases and deploy them. Like, what if you just need something to resize images? You can do that. You can sit there and say, hey, this function will run anytime I upload an image to my web storage, and then it'll be triggered, it'll grab the image, restore it. You don't have to create a full-on web running 24/7 web application to do that on a server that runs 24/7. You can have an AWS Lambda or Azure function that just does it when you need it done. So that creates all sorts of new use cases that were just inefficient before, or inefficient is probably the right word. But that hopefully gives you the concept of what all this stuff is, so that when you hear people talk about it and you watch tutorials on Docker, or you watch tutorials on Azure or AWS or Linode or DigitalOcean, you kind of know what's going on and what it is in the grand scheme of things. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.